And a big welcome to the European Spaceport in French Guiana, where Europe's rocket, Ariane 6, stands ready to launch. On board are two Galileo satellites, part of Europe's very own satellite navigation system. They're numbers 33 and 34 in the Galileo constellation, and they're scheduled to lift off in about 25 minutes' time. There's the countdown there on the top left-hand side of your screen. So it's a thoroughly European launch today, a European rocket carrying the next two satellites in a European constellation, giving accurate navigation to billions of us around the world. Stay with us as we follow this landmark mission. Over in Mission Control, the team's on console in the fishbowl behind that protective glass. And we are actually in our commentary box looking down over those operational teams. I'm Katie Haswell, and joining me is our rocket expert from Arianespace, David Iranzo-Gross. Thank you very much indeed, David, for being with us.
Thank you. Great to be here.
David, how's everything going?
So far, so good. The teams are preparing the launcher and the ground facilities for this launch. Everyone is getting ready for this very important launch for us and for Europe.
Absolutely. A very, very important launch today. And we've got quite a long journey ahead. It's going to take about 4.5 hours to deliver and check the health of our satellites. David and I are going to be with you the whole time. We'll, of course, be discovering our satellites. We'll be finding out more about operations across the range. We'll be seeing the Mission Control Center and obviously looking here at the other control center, David?
Yes, the Launch Control Center, the CDL3, where the teams are closer to the pad, and these are the teams responsible for the operations on the rocket and the launch pad.
We'll also be meeting the teams at the Quick Look Telemetry Centre, which is just outside the spaceport, and they will be taking on the baton, if you like, after launch, monitoring all the events on board our rocket. So let's go back inside Mission Control now to the fishbowl, and Caroline Arnaud, who is the Ariane Business Unit head at Arianespace. Caroline, thank you so much for coming to chat with us.
Good evening, Katie.
How are things looking for launch, Caroline?
Yes, boards are green, all systems are nominal, the teams are ready, fully focused on the chronology. So the operations are running smoothly, so everything is fully on track, and we look forward a beautiful launch tonight.
And tell us more about our passengers on board Ariane 6 tonight.
So on board tonight we have two Galileo satellites, SAT 33 and SAT 34. They are part of the 14th operational launch in Galileo program. Galileo is Europe's own global navigation satellite system. It is the world's most precise positioning system, and it currently provides services to 4.5 billion of users all over the world.
That's a lot of users. And as I said earlier, Caroline, it's a thoroughly European launch, isn't it?
Yes, by launching tonight two Galileo satellites for our key partners, ESA, European Commission and USPA, we are reinforcing Europe's own navigation system and also Europe's independent access to space, which is a key commitment for Arianespace.
And it's also a very important launch for Ariane 6, Europe's rocket.
Yes. Ariane 6 is off to an incredible start with 4 successful launches and the launcher available today on the launch pad. In less than 18 months, it is the fastest ramp-up ever for a heavy lift launcher.
Well, that's very, very impressive. Caroline, thank you so much.
Thank you.
And best of wishes to you and the teams. Thank you, Caroline. So we are scheduled to lift off in just under 21 minutes, David. What's going to happen after that?
So tonight Ariane 6 will lift off towards the northeast, targeting a 54-degree inclination orbit. It will be powered by its main cryogenic engine and the two solid propellant boosters. These boosters will be separated 2 minutes and 15 seconds after launch, followed a bit over 1 minute later by the fairing separation once the launcher has left the Earth's atmosphere. The launcher will then continue its ascent up to 7 minutes and 39 seconds when the main stage will have finished its job, and the onboard computer will command the shutdown of the Vulcan engine and the separation of the main stage. A few seconds later, the Vinci upper stage engine will be ignited for the first time, and it will burn for about 11 minutes, putting the launcher in a transfer orbit towards a medium Earth orbit. We will then have a long coasting phase, around 3 hours and 20 minutes, going up to 23,000 kilometers. And once we have reached this altitude, the upper stage will be reignited for almost 2 minutes, injecting the satellites into their final circular orbit, where they will be separated. The satellites will then start their autonomous operations, and the upper stage in parallel will be passivated.
So lots to come. And once they're on their orbit, it's going to take a few months for the satellites to be commissioned and readied to start their job. And it's an important job. Every time you order a pizza delivery, book a ride on a taxi app, or transfer money with your online banking, you are using global navigation systems. I think we don't always realise quite how important satellites are in making our everyday lives run smoothly. We've all got a little bit used to navigation, I think, in recent years. But Galileo is Europe's own satellite navigation system, and with more than 30 satellites in orbit, it provides highly accurate positioning, navigation and timing services to billions of us, as Caroline was saying.
Yes, it is reliable and precise, and very importantly, it is independent. So Galileo strengthens Europe's autonomy in space. Today, satellites 33 and 34 are scheduled to join the constellation to ensure the continuity of the service and to improve the robustness of Galileo by adding spares to guarantee that it can provide navigation services 24/7.
And today is the 14th time that batches of Galileo satellites will have launched into space, but it's the first time that they'll be riding on board Ariane 6, and she's going to take them all the way to just under 23,000 kilometres above our Earth. Let's find out more about them.
Tonight, from Kourou, the European Union is launching a new pair of satellites as part of its most ambitious space program, Galileo, the EU's own global navigation satellite system. With each new satellite, Galileo grows more robust and more independent. This launch marks the 14th operational mission of this inspiring program, known as Galileo Launch 14. Galileo is invisible, but its impact is everywhere. It is the world's most precise navigation system, serving over 4.5 billion smartphone users around the globe since it became operational in 2016. Whether you are checking a map, making a digital payment, synchronizing a network, or calling for help, Galileo, in the background, keeps your daily life running smoothly. At sea, Galileo satellites keep vessels on safe routes. In the fields, it guides tractors with centimeter-level precision. On the ground, it supports emergency services. For everyone, every day, Galileo turns a vague location dot into a position you can trust. Behind that reliability lies an architecture built for performance. Galileo is operated by the EU Agency for the Space Programme, EUSPA, and managed by the European Commission. Since its inception, the European Space Agency has been leading the design, development and qualification of the space and ground systems, as well as producing and carrying out launches. Galileo full operational capability satellites carry ultra-precise atomic clocks. This timing precision is the foundation of the system. From it, your receiver can determine position with centimeter-level accuracy. This new duo also broadcasts multiple frequencies at the same time, boosting resilience against interference. Aboard Ariane 6, Galileo satellites 33 and 34 will join in about 3 months, a constellation orbiting more than 23,000 kilometers above Earth. Each spacecraft is a small piece of a larger ambition that Europe continues to maintain an independent navigation system designed for global users who rely on stability, accuracy, and trust. In a world shaped by instant communication, navigation is a pillar of our daily life, our society, economy, and safety. And that is why this mission matters. Each Galileo satellite added strengthens a system that supports modern life in ways we rarely see, but constantly depend on. Galileo continues to grow, quietly building a future in which Europe navigates with confidence.
And today we're launching the 2 first-generation satellites, but the next generation is soon to follow, isn't it?
Yes, after tonight there will be 2 additional Ariane 6 launches with Galileo first-generation satellites, which are built by OHB in Germany. And the second-generation Galileo satellites is now in preparation. Satellites are being designed and manufactured by Airbus Defence and Space and Thales Alenia Space. And these new and more powerful satellites will be launched 2 at a time, stacked on top of Ariane 6.
14 minutes to launch. Back in mission control, all the status panels are green. And do you want to talk us through what the systems are? We're looking here at the teams here in the mission in the fishbowl.
These are the ESA teams following the satellite.
The status panels, David, we are looking at 3 different systems, aren't we? Oh, and actually, quickly, just let everybody know, this is the flight desk.
Yes, here we have the management teams of Arianespace and Arianegroup that are following the launch.
So talk us through the status panels.
So yes, we have 3 main systems across the base. The launcher with its ground systems, what appears as Ensemble de Lancement Lanceur. We have the satellites, of course, the Galileo satellites, and a third group, which is the range, which includes the telemetry, radars, weather, and safety systems that are needed for the launch.
And all of those need to be green, of course, for a launch to go ahead. So we were mentioning earlier we have another control centre, launch control, very close to the pad. What are the teams in here doing, David?
Yeah, the Launch Control Center, or CDL3 as we call it, it's a concrete bunker that's 5 kilometers from the launch pad. And these are the operations teams. They are sending the commands to the launcher and to the launch pad systems, turning the launcher avionics on, filling the propellants in the tanks, pressurizing the tanks and opening valves, doing all the planned checks that we need to do before we go for launch. And also, right next to them, we have the engineering teams who are closely monitoring all these operations. They are making sure that all the parameters, here they are, that all the parameters are in the specified ranges in terms of temperature, pressures, electrical currents. And they also have the support of teams back in Europe who are there to help in case of need.
Very important that as many people as possible on the job, and of course teams in Europe seeing a mirror of that data coming in. The final weather check's coming up in about 1.5 minutes. Obviously the weather's important. All the conditions must be right for a launch to go ahead. And the European Spaceport is on the Amazonian coast of French Guiana in South America, so we do get a lot of rain. And actually, it has been the beginning, really, of the raining season recently, hasn't it?
Yes, we've had some rain these past few days, but yes, rain is not the problem. We need to monitor a couple other things. One of them is the high altitude winds between 10 and 20 kilometers. We need to make sure that wind speed and direction are within a certain limit in case of problem during the launch. And also we need to monitor the lightning risk. During the ascent, we need to avoid any lightning on the launcher. On the ground, we have the lightning masts that protect the launcher.
And we have a weather station here at the spaceport. How do they actually monitor the weather? What do they use?
So there are predictions that are made, very accurate predictions, and they use, for example, the balloons that we see here, which carry sensors into the upper atmosphere, sensors that measure temperature, pressure, humidity, and these elements are taken into account in the prediction models to have accurate wind predictions and lightning predictions.
And the boards have remained green. The weather status panel is green, so that's a good sign. That means that we are go for launch when it comes to the weather. Teams have been working here at the base now for some time preparing. What have they been doing, David?
So the elements of the launcher arrived on the canopy boat that you see here, a new hybrid boat using sails for its propulsion. The elements of the launcher arrived in August. They were transported to the spaceport by road to the horizontal assembly building, where we have the assembly of the main and the upper stage horizontally, the mechanical mating, and then the checks, electrical checks. Once this is done, the whole central core is transported to the launch pad, which is 800 meters away, using these automated vehicles. Once the core is on the launch pad, it is put in vertical position, and then it is hoisted and put on top of the launch table. Once this is done, the boosters come to the launch pad as well, and everything is assembled together. On the passenger side, the Galileo passengers arrived in French Guiana on November 6th, just over 1 month ago. They were prepared during 4 weeks. They were fueled, checked, and then they were integrated around the dispenser, which is the golden structure that you see here. So the two satellites were attached on it, and then they were transported to the encapsulation building, where the satellites and the dispenser were integrated on top of the launch vehicle adapter that you see here, and then the fairing was put around it. And once this was done, the whole structure was ready to go to the launch pad. So it was transported there just a few days ago, and then it was put on top of the launcher, where the final connections were made and the final checks were made in preparation for the launch today.
And now here we are, 7 minutes and 32 seconds to launch. But the final countdown actually started over 8 hours ago, and there have been lots of different operations during that time. Do you want to run us through some of the highlights?
Yes, the countdown started, in fact, even 11 hours ago, but the main event was the removal of the mobile gantry, which happened 8.5 hours before the launch. After that, the propellant lines were flushed to get rid of any leftover humidity, and then the lines were cooled, and the start of the fueling of the tanks began at that point 5.5 hours ago, 5.5 hours before launch. And in parallel, there have been electrical checks, armings of the pyrotechnic systems, and we on the launch base site, we had the telemetry and radars being ready for launch. So now we are in a stable situation, and we are waiting for the start of the synchronized sequence, which will take place in a bit over 1 minute.
Nice shot there of the whole pad. We can see the lightning towers that you mentioned there, David. Just describe what we're looking at. We've also got some fire down at the bottom right. That's perfectly normal.
Yes, that's right. That's what we call the hydrogen pool, where the excess hydrogen is being burned But yes, as you say, that is totally normal.
And we can also, you can't really see them very well, but at the bottom of the right and left of your screen back there, you could actually see what we call the calno, which are the exhaust, big blocks of concrete where the exhaust will come out. Getting close now to the 1 minute mark. Everybody looking at these screens here in the Mission Control Center. The Range Operations Manager today is Raymond Boyce, and he's going to be calling out all the major milestones during the launch. And it's Jean-Frédéric Alazin. In fact, I made a bit of a mistake there. My apologies, Jean-Frédéric. So he's in charge of coordinating the launch-based systems during the final countdown. And as I said, he'll be calling out all the major milestones.
And yes, we have had the start of the synchronized sequence,
which is the last final 5 minutes in the countdown. Lots of operations during this time.
Yes, lots of operations, very precisely timed, combining the last checks, the last pressurization of the tanks, the activation of the different systems, and opening of the valves on the launcher. And the control of the operations is gradually being handed over from the ground systems to the onboard computer, and it will be actually the launcher onboard computer who will decide on the start of the main engine, and who will then send the command to the boosters for ignition.
So we're getting close now, concentration levels high. We're looking there, we can see a good shot of the Vulcan engine on the main stage of the rocket. Now let's just run through a few things to watch out for. That Vulcan engine, David, is going to switch on 7 minutes, isn't it? 7 seconds before launch.
Yes, that's right. There will be the ignition of the main engine, and then there will be checks that will be performed, making sure that it is running as expected. And once this is done, then the command will be sent for the ignition of the boosters. And once this happens, there is no holding back. 400 milliseconds after that, the launcher will lift off.
Only 400 milliseconds between ignition, between the command and the actual liftoff. Very quick. If you look at the top of the rocket, can you see those yellow sections on the right and left? Those are actually the cryogenic arms clamping onto the top third, onto the upper stage of the rocket, feeding very, very cold propellants into our rocket.
Yes, they're feeding cryogenic oxygen and hydrogen. As you say, they are very cold, and so they are continuously evaporating, and therefore we need to continuously fill in the tanks up to 3 minutes before the launch. So we just stopped a few seconds ago, and these arms will retract just a few milliseconds before the actual liftoff.
And sometimes you can see, depending on the camera angle, you can see a little bit of white smoke, what looks like white smoke, coming out of the top of the rocket. But it's not actually smoke, is it? It's
it's condensation of the humidity in the atmosphere here in Kourou, which is very high.
We'll also see the umbilical lines retracting and pulling away at liftoff.
Yes, that's right. The umbilical lines, which carry electrical power and ventilation to the launcher and to the satellites. And this will be automatically disconnected as the launcher moves up.
1.5 minutes to launch now, getting close. Nice shot there of the Vulcan engine on the main stage. Just a reminder that that's going to switch on 7 seconds before the boosters. And once the boosters ignite, we lift off. We have a 15 second...
de DDO. Attention pour moins 1 minute.
Irreversible sequence at minus 15 seconds.
Top H0 moins 1 minute.
we are 1 minute to launch. Best wishes to all the teams and to the Galileo satellites 33 and 34 as they get ready to start their journey. Good luck, everyone.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage des ESR et décollage. Tout basculement. Les paramètres à bord sont normaux. Trajectoire nominale, les paramètres à bord sont normaux.
And we are off. Satellites 33 and 34 in Europe's satellite navigation constellation have started their journey on board the continent's Ariane 6 rocket. Galileo satellites are on their way. We are supersonic. We've
La propulsion
broken
est
the
nominale.
speed barrier. The range operations manager is telling us that everything is going according to plan. And we are hearing the rumble of the rocket as it flies over our mission control center about 16 kilometers away from the pad. It's taken over a minute, about a minute and a half for that sound to come to us. Right-hand side of your screen, we're looking at the telemetry information coming in from our rocket. David, that's the curve on the top right-hand side.
That's right, yes. So the green line is the prediction and the yellow line is the actual position of the launcher. So we see that we are right on the spot.
And below that, our altitude. And we're presently 43 kilometers and climbing above Earth. Our distance from the pad, if you were to draw a straight line, and our speed. Right, our boosters are doing all the work, David, aren't they?
Yes, that's right. About 85% of the thrust needed, and they will be separating in just a few seconds at 63 kilometers altitude.
Trajectoire nominale. Séparation ESR.
And we have confirmation there from our range operations manager that those boosters have been separated as planned. So, we are losing weight. As you say, that's the name of the game, to jettison as much mass as possible as we go through the flight. And we're burning 3 engines, as we said. We switched on the Vulcan 2.1 on the ground on the main engine and the boosters. But as we said, the boosters really were doing all the work. Now, we don't need them anymore. The fairing at the top of the rocket is where our satellites are housed at the present time. That will be the next thing to be jettisoned. What's it protecting us from?
So the fairing protects the satellite on the ground from dust and humidity, and then during the launch from the acoustic vibrations of the launch, and also, of course, from the friction and the heat during the ascent through the dense parts of the atmosphere. And it will be separated once we don't need it, meaning at around 110 kilometers, so very soon.
There we go, that's how it looks.
Séparation des coiffes, trajectoire nominale.
Confirmed by the range operations manager, who's also telling us that the trajectory is normal. And you can see there our altitude, 116 kilometers now above Earth. So we've crossed what we call the Kármán line, if you like, the border with space. And we can see our satellites for the very first time, David, and they can see space.
Yes, that's right. The image shows the launcher with the satellites and the dispenser on top of the launch vehicle adapter, the black cone on top of the launcher. This is the simulation. These images are a simulation based on the outputs of the trajectory calculations, showing the launcher as it should be right at this moment.
Indeed, the simulation is very much a very useful thing for us to be able to see. We call it the 3D or the CGI images, and they use the gaming software Unreal Engine to create those images. So, as we said, our trajectory on the right-hand side, and below that you can just see actually the people there in the Launch Control Center, David, now watching the launch.
That's right. Their job is finished, but they are, of course, following the launch very closely.
So, we are burning the main engine. It's a great big tank of fuel. You can see it there.
Yes, it's 32 meter high, 5.4 meter diameter, and it's full with 154 tons of liquid oxygen and liquid hydrogen. The chemistry of these two elements leads to one of the most fuel-efficient combinations that exist for rocket propulsion, meaning that for a given amount of propellant, we will get the highest acceleration transferred to the launcher and to the satellites.
He's telling us that we've got 2 minutes left on the burn on the Vulcan engine. And it is indeed a powerful engine, isn't it, the Vulcan 2.1?
Yes, it's 135 tons of thrust in vacuum, and it burns the propellants in around 7.5 minutes, increasing the speed and the altitude. Today, we will go up to 5 kilometers per second with this stage and up to an altitude of 200 kilometers. And this engine actually has been optimized with respect to Ariane 5. The nozzle manufacturing has been optimized. There are some additive manufacturing elements that have been added, like the gas generator. And also we have added a thermal protection on the nozzle that we saw before on the launch pad to protect it from the heat from the boosters during the launch.
So you can see our altitude, 169 kilometers, so we're increasing our altitude and increasing our speed. At the moment we're 3.4 kilometers actually per second. And actually, we not only are we travelling fast and getting higher, but we're actually rotating, aren't we, very slowly?
Yes, that's right. There is a small rotation that is done in order to keep the heat on all parts of the launcher at the same rate. He's
telling us everything's going well. David, it's quite interesting actually, because we launched, didn't we, 2 Galileo satellites from the Guiana Space Center exactly 10 years ago today.
Yes, that's right. On this 17 December 2015, there was the launch of Launch 6 of Galileo with satellites 8 and 9 that were launched, yes, exactly 10 years ago.
So everything's going well, coming up to the next main event, and that is the switching off of the
Séparation
main engine.
LLPM.
And we have confirmation
Fin de mission sauvegarde.
that main stage has now been separated and jettisoned.
Vinci.
And the Vinci upper stage engine has now switched on and the propulsion is normal. And we are being tracked now by the naval tracking station. It's actually on a boat, isn't it?
Yes, that's right. For today's mission, flying northeast across the Atlantic, there is no tracking station on the ground that can see this part of the trajectory. Therefore, we use a mobile tracking station that is installed on a boat, and we position the boat in the right place in the middle of the ocean to be able to follow the launch.
So the upper stage is very much now in charge. It has a super important job to deliver its passengers to their required dropping off point, if you like, in space, their required injection point, and that is a very specific and precise place. We've got a new engine for the Ariane 6 upper stage. It's called Vinci, as I mentioned earlier, and it's a very sophisticated piece of kit.
Yes, the Vinci engine on the upper stage is one of the big innovations of Ariane 6, which provide mission flexibility. It is designed, they are designed to be switched on and off up to 4 times, which allows to take different satellites to different orbits, but also to go to high circular orbits, like it's the case today, to MEO or even to direct geostationary orbit. And for this mission today, we will use the engine twice to deliver the Galileo satellites to their destination.
And the company which builds the rockets is Arianegroup. And with the support of ESA, they're developing a new stage for Ariane 6. Wow, that looks very exciting.
Yes, Astris will give Arianespace the capacity to perform even more complex missions on Ariane 6.
Even more flexibility, so that's really good. 13,000 or so people across Europe are involved in creating Ariane 6. That's what you call teamwork. One of those companies makes the pyrotechnics for separating the sections. They're called Pyro Alliance.
Pyro Alliance is a subsidiary of Arianegroup, which designs and manufactures pyrotechnic equipment for space, aeronautics and defense. We've been supplying the Ariane family for several decades now, with more than 100 kilometers of pyrotechnic cords delivered and thousands of equipments that have operated with a 100% success rate. We are close to 300 collaborators dispatched on 2 sites, in Les Mureaux and in Toulon, both contributing to the Ariane 6 pyrotechnic chains. The principle of a pyrotechnic chain is simple. The chain performs a signal transmission along pyrotechnic lines which carry the energy necessary to trigger the terminal functions. We contribute to many terminal functions on Ariane 6, which are all mission critical. The ignition of the solid rocket motors, the separation of the boosters, the ignition of the retro rockets, the separation of stages, and finally the flight termination system, which is a mandatory safety function securing the rocket destruction in case of hazard during the flight. The benefits of using pyrotechnics are the very short actuation time and a very robust technology which is immune to the extremely harsh environments that the launcher has to face. The challenge when you develop such products is that you have to prove a reliability of 1 in a million on products which are one-shot and cannot be tested before flight. For Ariane 6 we have in particular developed a brand new family of lead-free products, linear shaped charges, detonating cords and transmission lines. Last but not least, based on the customer's choice for each launch, we also offer hold and release mechanisms for the dispensing of the payloads. Aero Alliance and all its employees are very proud of contributing to Ariane 6, the launcher that will durably secure the European access to space, and we are fully committed to perform a successful ramp-up for the program.
Alliance doing some really important work there. And during that film, we locked onto the signal at the Santa Maria tracking station. That's in the Azores. The 9 volcanic islands, actually, in the Atlantic, isn't it? So our flight path, David, takes us northeast, you were saying?
Yes, we are going northeast over the Atlantic, in fact very close to the airplane route that flies from Paris to French Guiana. And we will soon be flying over Europe and then down through Central Asia and Australia.
And the rocket talks to us. It sends us a signal to the tracking stations as it flies over, and they then collect data about how things are going on board, and they relay those data to the Quick Look telemetry team.
Yes, the CVI team, they are collecting real-time data, which the launcher is sending through the different tracking stations, and this data includes the status of the engine, the trajectory, and the flight control. And they are comparing this live data from the rocket to what has been predicted. And this allows them to continuously analyze the behavior of the launcher and confirm that everything is going as expected. This is the information we are getting regularly. And of course, they will also be able to confirm once the satellites have been separated in their final orbit.
And the range operations manager is listening in on their comms loop. And once they've confirmed major events, he's then able to call those confirmations out to the rest of us here at the base. Let's take a quick look again at our telemetry information coming in on the right-hand side, David. We're travelling fast.
Yes, we are now close to 9 kilometers per second and with an altitude of 150 kilometers.
And the range operations manager is telling us that everything is going normally and according to plan. Now we have we're travelling faster and faster and faster. We need to be climbing higher, don't we, later in the flight and really climbing up into space. We've got a long way to go. We've got to go quite high today.
Yes, that's right. We will be climbing. We will be picking up speed and then climbing up to a high orbit, close to 23,000 kilometers.
And we're looking here at the satellites attached to their dispenser. That's the gold structure in the middle there between the two satellites.
Yes, that's right. It's it's a composite structure. It's a dispenser similar to the one that was previously used for Galileo launches on Ariane 5 and on Soyuz. And it has been, of course, adapted to Ariane 6. And this structure includes the hold and release mechanisms that keep the satellites attached during the ascent, and that will gently separate the satellites once they reach their final destination.
We are now at an altitude of 165 kilometres and climbing. We've travelled quite a distance, 5,222 kilometres across. If we were to fly across our planet, that's the distance that we've flown. And we're now, heading up to 9.62 kilometres there per second in speed, which is something above, I think, 28,000 kilometres an hour. So we are going fast. And we've had confirmation there.
We are coming up with the...
I thought I heard confirmation of the extinction of the Vinci upper stage. And that's how it looks up there.
Okay.
And he's also telling us that the APU is functioning normally, and the first major step, therefore, has been accomplished in reaching the desired orbit. We're now coasting without our engine. Why do we switch it off now, David?
Well, we have reached the necessary velocity, and Ariane 6 is on an elliptical orbit around the Earth now. At its closest point, what we call the perigee, the rocket is about 150 kilometers above the Earth. And at its farthest point, what we call the apogee, we will reach close to 23,000 kilometers, the altitude of the Galileo constellation.
Indeed. And I do believe that we are flying and heading towards Europe there. I can see the UK, and I can actually see the lights of London emerging. I can just see the sort of west coast there of the UK, Wales, and beautiful Devon and Cornwall. That's my home country, so it's nice to fly over and say hello to everybody in the UK. Let's turn our attention now to our satellites. He's telling us that everything is functioning completely normally. Now, the European Space Agency is responsible for carrying out the Galileo launch, along with Arianespace, and as Galileo's prime and design authority, ESA has guided the program from its earliest days. I'm delighted to be joined by Javier Benedicto, who is the Director of Navigation at the European Space Agency. Javier, thank you so much for coming up to the commentary box to talk to us.
Good morning, Tracy. Good morning, everyone.
Yes, indeed. Good morning. With satellites 33 and 34 now joining the fleet, how does Galileo strengthen Europe's autonomy and resilience in navigation and timing services? Before you answer the question, I'm just going to mention that I think I've heard the range operation say something about the station, but anyway. Yes, so tell us all about that.
Well, Galileo has become an essential piece of infrastructure.
Start again, please, Javier, because your microphone wasn't...
Thank you, yes. Galileo has become an essential piece of infrastructure for Europe. It is serving billions of users worldwide, and it is serving our society, economy, but also our safety and critical applications. So Galileo has to work all the time. We have to improve the performance and improve the robustness, and this is exactly what these two satellites are going to provide. So we have a responsibility to actually make the system perform better and better, and to make it work at all times, even if we have any sort of anomalies in orbit of the satellites which are already serving the constellation. With these two satellites, we're providing for additional redundancy and the necessary resilience for all the applications that Europe wants to provide through Galileo.
And looking ahead, what's next for the constellation?
We still have 4 satellites of the first generation, which we're going to launch in 2026 and early 27, and we are producing at the time 12 satellites of the second generation, which are going to provide for additional power, more power on ground, which is very important for a variety of applications, but also a lot of flexibility in order to reconfigure the satellites while being in orbit, because they last 15 years, 12 to 15 years, and the market changes all the time, so we need to be able to reprogram our satellites in order to match the needs of the users.
That's very important, isn't it? And I mean, what about just taking the next step now and looking slightly further into the distance in the long term? I mean, what are ESA's plans for continuing the competitiveness?
We need to continue improving our technology because as the market is developing, the needs are becoming more and more demanding. So we have to improve performance, obviously, but in particular improve the robustness of the system. And for that, we are going to test in the coming years new technologies. We want to equip our Galileo system with optical intersatellite links, which will provide for increased means of accuracy and robustness of the services on ground. We will in future make use of also quantum technologies, and we are going to launch very soon the first European satellites for navigation in low Earth orbit. A program we call Celeste in European Space Agency, and which will hopefully set the grounds for a new layer, a new segment to augment Galileo in the future.
Gosh, there's a lot going on. You're going to be very busy, aren't you? Listen, thank you very much indeed, Javier, for coming and telling us all about that. And best wishes now to you and all the teams for the next phase. We are now climbing high to our orbit. It's going to take us about 3 hours to get there. We've got to climb up to just under 23,000 kilometers above our planet. So we're going to take a little break. We're going to come back to you at 8:35 Universal Time, which is 9:35 in the morning in Europe, and at 5:35 here in Kourou. So we will see you back here then.
Acquisition de la télémesure par la station Nunorcha. Fonctionnement APU nominal. Le pilotage est calme. Tous les paramètres à bord sont normaux. Le vol se poursuit nominalement, les paramètres à bord sont normaux. Les paramètres à bord sont nominaux, le vol se poursuit nominalement. Tous les paramètres à bord sont normaux, le vol se poursuit nominalement. L'APU fonctionne nominalement, le pilotage est calme, le vol se poursuit conformément à l'attendu. propulsion nominale, tous les paramètres à bord sont normaux. Le pilotage est calme, les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux. Les paramètres à bord sont normaux, le vol se poursuit nominalement. Fonctionnement APU nominal, le pilotage est calme, le vol se poursuit nominalement. Poursuite nominale du mode barbecue, les paramètres à bord sont normaux. Fonctionnement APU nominal, le vol se poursuit nominalement. Les paramètres à bord sont normaux, le vol se poursuit nominalement. Vol nominal, les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux. paramètres à bord sont nominaux. Le pilotage est calme, tous les paramètres à bord sont normaux. Le vol se poursuit nominalement. Tous les paramètres à bord sont normaux. Le fonctionnement APU est nominal. Tous les paramètres à bord sont normaux. Tous les paramètres à bord sont nominaux. Poursuite nominale du mode barbecue, tous les paramètres à bord sont normaux. Le pilotage est calme, tous les paramètres à bord sont normaux. Poursuite nominale du mode barbecue, tous les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux. Le vol est nominal, tous les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux, le vol se poursuit nominalement. Pilotage calme, tous les paramètres à bord sont normaux. Fin du mode barbecue. Début de la manœuvre d'orientation pour la phase 0G. Les paramètres à bord sont normaux. Fin nominal de la manœuvre d'orientation. Extinction APU. Allumage APU. Allumage APU nominal, les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux.
Launch 14, live here at the Guiana Space Centre. The next two satellites in Europe's Galileo satellite navigation constellation are on their journey. 2 hours, 5 minutes and 1 second into their journey on their way to their injection point in space. That's the place where we will be dropping them off and delivering them. They need to travel to an altitude just under 23,000 kilometres above our planet. They have been climbing and climbing. Right now they are 18,397 kilometres up and climbing even higher. You can see the altitude on the bottom right of your screen. At the moment we're in what we call a ballistic phase. We are coasting without the engine as we climb to that orbit. We're going to come back to you. Our commentary will resume at T plus 3 hours and 33 minutes. So 3 hours and 33 minutes after liftoff. The countdown on the top left-hand side of your screen.
Le pilotage est calme, tous les paramètres à bord sont normaux. Fonctionnement nominal de l'APU, le pilotage est calme, les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux. Le vol se poursuit nominalement. Pilotage calme, tous les paramètres à bord sont normaux. Le vol est nominal, tous les paramètres à bord sont normaux. poursuite nominale du mode barbecue, le pilotage est calme, les paramètres à bord sont normaux. Les paramètres à bord sont nominaux, le vol se poursuit nominalement. Propulsion nominale de l'APU, les paramètres à bord sont normaux, le vol se poursuit nominalement. Tous les paramètres à bord sont normaux, le vol se poursuit nominalement. fonctionnement nominal de l'APU, les paramètres à bord sont normaux. Tous les paramètres à bord sont nominaux. Poursuite nominale du mode barbecue, le pilotage est calme, les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux. Le pilotage est calme, tous les paramètres à bord sont normaux. Pilotage toujours calme, les paramètres à bord sont normaux. Pilotage calme, les paramètres à bord sont normaux. Fonctionnement toujours nominal de l'APU, le pilotage est calme, tous les paramètres à bord sont normaux.
Of the next two Galileo satellites in the Europe's Galileo satellite navigation constellation, on their way to their final destination in space, where they will be dropped off by the upper stage of Ariane 6. Right now they are attached, as you can see there, to the upper stage of the Ariane 6 rocket. Two of them, one on each side of the gold structure. Right now we are in a coasting phase, and we are going to be coasting for just under half an hour more, and then getting close to switching on our engine after that. We will be coming back to you with our live commentary at T plus 3 hours and 33 minutes. That means 3 hours and 33 minutes after liftoff. You can see the countdown there on the top left-hand side of your screen. Right now we are climbing. We have a little bit further to climb. We need to get to just under 23,000 kilometers above our planet. We've been climbing higher and higher into space, and we're nearly there. So please come join us for the next part of our program. We've got lots of exciting things to look forward to. So we will see you back here at T plus 3 hours and 33 minutes.
Les paramètres à bord sont normaux, le vol se poursuit nominalement.
Le pilotage est calme, tous les paramètres à bord sont nominaux.
Fonctionnement nominal de l'APU, les paramètres à bord sont normaux. Fonctionnement nominal de l'APU. Pilotage calme, les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux. Poursuite du mode barbecue, tous les paramètres à bord sont normaux. Poursuite nominale de la mission, les paramètres à bord sont normaux.
Transporting the next two satellites in the Galileo constellation, travelling on board Europe's Ariane 6 rocket. I'm Katie Haswell, and with me still is David Aranzo, our rocket expert from Arianespace. Thank you very much for sharing your expertise with us, David. It's very valuable.
Thank you. Good to be here. Yeah.
So, Ariane 6 lifted off from the pad just after 2 o'clock local time. That was 3 hours and 37 minutes ago. You saw those beautiful shots there of the liftoff. It was quite stunning. From the European Spaceport here in French Guiana, everything performed like clockwork. David, remind us what happened.
So yeah, we had a great liftoff a few hours ago. We had the first part of the flight with the booster flight, and then the opening of the fairing once we got out of the atmosphere. We continued for 8 minutes with the propulsion of the main stage, and then we had the separation of the main stage and a first boost of the Vinci upper stage, which lasted 11 minutes, putting us into a long coasting phase that will last 3 hours and 20 minutes altogether. And in just a few seconds, we will have the reignition of the upper stage, putting us into the final orbit.
Indeed, and as you say, we're waiting for the Vinci upper stage to switch its engine back on. But what's actually happening up there in space, David?
Well, right now we are putting the stage. There's a slow rolling of the stage, what we call the barbecue mode, that is turning the stage very slowly, and the stage is now prepared for the ignition.
Allumage Vinci.
And we have confirmation there from the range operations manager that the engine has now been switched on for the second boost. And that's a big moment. It's an important moment. Every switch on and switch off of an engine is important in space. Why do we need to switch the engine back on right now?
So up to now we were on an elliptical orbit with an altitude at 23,000 kilometers, but a low perigee, and now we need to circularize it. And in order to do that, we need to add energy. We need to add about 1 kilometer per second of velocity, and that's why we see the speed increasing now, and it will increase up to 2.6 kilometers per second, and that will mean that we are on the circular orbit. And so it will now last a bit less than 1 additional minute of propulsion.
And the teams who are tracking us are at the New Norcia tracking station. They're collecting the data from the rocket as it flies over. You can just see Australia in the distance, actually. New Norcia is indeed in Australia. And the information is coming through, or the telemetry information coming through on the right-hand side of your screen. The curve is the projected trajectory, and the white cross the actual position of the rocket, and then underneath that you've got the altitude, the distance from the pad, and our speed, vitesse in French.
Extinction Vinci.
And the range operations manager has now confirmed the switching off of the upper stage engine for its second switch off, which means we are now in what we call the ballistic phase, the second ballistic phase, coasting without the engine. And the range operations manager telling us that everything's going nominally. Now, as space threats grow more sophisticated, Europe needs to be robust, not just for now, but also for the future. And at the heart of this effort is a vital agency, the independent EU Space Security Accreditation Board. Since 2010, they have been approving the standards. that keep Europe's satellites and space services secure. And I'm delighted to say that joining me now is the chairman of the Security Accreditation Board, Philippe Bertrand. Philippe, thank you very much indeed for coming up to join us. I believe you watched the beginning, you watched the launch from quite close up.
Yes, we were in Toucan. It was really nice. It was a fantastic launch.
Yeah, nice to see it with your own eyes rather than on the screens. Philippe, tell us, what is the role of the Security Accreditation Board in general, and also specifically for Launch 14, for this launch?
The EU Space Security Accreditation Board is the security accreditation authority of all the EU Space Program components. Galileo, EGNOS used by civil aviation, Copernicus devoted to Earth observation, Space Situation and Tracking, and the satellite component, GovSatcom and IRIS². Within the Security Accreditation Board, the member states make accreditation decisions independently of Commission, EUSPA, and the European Space Agency. To prepare this campaign, we define the security measures to be put into place, and we have had a dedicated team here in Kourou working on a daily basis with the European Space Agency. As always, the cooperation has been excellent, and we have been in positions to authorize the launch 2 days ago.
And once the satellites are on their orbit, what's the role of the SAB towards the Galileo services? And also, how do you actually work to address the threats?
This evening, in fact, we launched 2 satellites to integrate the Galileo constellation. But the ultimate goal of the program is to provide services to the government or to the citizens. One famous service, Galileo service, is the public regulated service. It is the most secure service of Galileo with encrypted signals. And to prepare the authorizations to enter into operation, hopefully by next year, we perform a lot of audits on cyber penetration tests. And to do that, we have a team of cyber experts in charge to prepare cyber attack on Galileo. And when we launch the cyber attack on Galileo, we evaluate the robustness of the system and the operator to respond appropriately and maintain the service. When we have done all those evaluations, it is our duty at Security Accreditation Board to authorize the service declaration. So it would be a great objective and a great achievement for the program to have the public regulated service entering into operation in 2026. We work for that.
Oh, good. And why is security so critical for Galileo?
Alors Galileo, it's a strategic program. It's the European autonomy for position, navigation and timing. And we know that we are in a difficult geopolitical context where EU is regularly under attack. And the more Galileo will be used for critical application, the more Galileo will be used for defense, the more we may be under attack. And it is the Security Accreditation Board responsibility to ensure ultimately, and in total independence, that the program met the security objective, that we know the risk, and that we are ready to counter the threats. This independence is the cornerstone of the confidence the government and the users may have in the Galileo program. So after this launch, let's continue to work together to ensure we have good services for us all.
Yes, yes, indeed. Well, obviously, really very, very important work that you and the team are doing there, and we're all very grateful for that. Thank you very much, Philippe, for coming to join us. Philippe, back to the flight. Right now, New Norcia is tracking us, as I said. You can see down on the Earth, you can see Australia, Antarctica, and the Earth there in the distance, and the teams at the New Norcia station will be focusing very hard at this point now as we get closer to our separation. And that, as I said earlier, that telemetry information coming in on the right-hand side of the screen, you can see we're 22,931 kilometers high. Now the tracking stations are sending their data, relaying it back here to the Guiana Space Center. We saw the quick look telemetry team earlier. They're actually on a hill outside. He's telling us that everything's going according to plan. That's the voice there of the range operations manager that you can hear. And here they are, the quick look telemetry team. So they're receiving all the information that comes in from the tracking stations, and the range operations manager telling us that we have the beginning here of the orientation maneuver in order to prepare for separation of our satellites. So yes, the telemetry information coming through here to the quick look telemetry team, and they're making a selection and able to cover an awful lot of data coming in from the rocket, so that we can hear what's going on up there in space. They then relay that information to the range operations manager. It's a dynamic job. It's a high-powered and pressured environment, incredibly rewarding. It's a small team, but essential to the success of the mission. Everything's going normally. The European Commission is at the helm of the Galileo satellite navigation program, which it owns and manages on behalf of the EU. And while the European Space Agency builds and tests the satellites, and the EU Agency for the Space Program runs daily operations, it's the Commission that provides the political leadership and oversight. In short, the European Commission is very much the backbone of Galileo, guiding Europe's path to secure, sovereign navigation in space. Well, joining me now is the Director for Space Policy, Satellite Navigation and Earth Observation at the European Commission, Christoph Kautz. Christoph, thank you very much indeed for joining us, and switch on your microphone. Christoph, tell us, why is Galileo so important for Europe?
Well, thank you very much, and good morning to everybody. Yes, why is Galileo so important? I would say there are three main points to be made. First of all, it's very important in terms of strategic autonomy for Europe, being autonomous in terms of satellite navigation. And that was the primary purpose of building Galileo, but today I think in the geopolitical environment it's clear that it is crucial to have the strategic autonomy. Second is, it's very important also for the EU's economy. We estimate that 10% of the EU's GDP is enabled by satellite navigation, and it's easy to understand. To go from A to B, to fly a plane, to withdraw money, to synchronize electricity networks, you need satellite navigation signals for that. And the third point is resilience. So in case of crisis, let's say thunderstorms, and the ground-based infrastructure doesn't work anymore, well, satellites will continue to work, and that relates also back to my first point on strategic autonomy.
And yes, so very, very important indeed. But what's the significance then of today's launch?
Well, today's launch is significant, I would say, in two aspects. First of all, because we are showing that we have secured autonomous access to space. I think that's now very clear with this further launch of Ariane 6. And second point, it's very important for the Galileo constellation, because as satellites are aging in space, we need to replenish regularly the constellation, and we are doing this again in an autonomous way thanks to Ariane 6.
And space missions like this require years and years of collaboration, a lot of teamwork, people working hard together, working all over, and lots of different companies. I mean, these kinds of space projects are huge, aren't they? Just give us a little sort of behind the scenes kind of an idea of what's involved in preparing for a launch like this.
Well, in preparing for a launch like this, of course, there are things you could say, this is the boring side, but you have to negotiate contracts, you have to ensure that you have money in your budget to do it. Then once you have ensured that you have money, that you have negotiated the contracts, you need somebody to supervise that all is going in the right direction. But it's not only about, preparing the launch and having the satellites. You have the whole ground segment that has to be in tune with the launch and the satellite. So also you have to ensure that your ground segment is up to date for the launch, and you need somebody to operate the ground segment as well. So you see, there are many things that have to fit together to make this possible. So it all seems, I wouldn't say easy, but it works, but there is a lot behind that.
Sounds like a very complex jigsaw puzzle. And what can we look forward to next in the Galileo program, Christophe?
So I think there are three things. Short term, we will roll out further services. We want to roll out the service specifically for security and defense called Public Regulated Service. We want to roll out a so-called emergency warning service where we can inform population in case of disasters, where the ground-based GSM network doesn't work anymore. So this is more short term. Medium term, we are working on Galileo second generation, and we are due to launch, hopefully in 2027, the first second generation satellites. And more longer term, we are working on LEO PNT, so low Earth orbit positioning, navigation and timing. That means putting satellites closer to the Earth, which ensures a more robust signal.
Wow, there's a lot going on then. You're going to be very busy. Christophe Kautz, thank you very much indeed for joining us. Thank you. So we are getting ready now, getting closer to the separation of our satellites, and we have to deliver them to very specific, very precise orbits. And you can see that we're on our altitude. We've plateaued out up there on our curve, so we're on the right altitude here, and we're travelling at a fixed speed there, 2.61 kilometres per second. David, just talk us through what's actually happening up here in space, because we're going through a very precise set of orientation manoeuvres, aren't we? I mean, it doesn't look like much is happening, but actually it is.
Yes, the upper stage has been turning very slowly, putting the satellites in the precise orientation needed to perform the separation. And this precise attitude is needed to make sure that the satellites will be moving away in the right direction after separation, away from each other and away from the upper stage. And these maneuvers are now finished, and so the separation will take place in just a minute. The satellites are being separated 300 kilometers below their final operational orbit. So after separation, the satellites will use their own propulsion system to move up to the final position in their operational orbit. The type of trajectory we are doing today is similar to what we do on a geostationary transfer orbit, except this time the launcher, the upper stage, is doing also the injection into the final orbit.
And how does it do that? How are the satellites actually injected or separated from the upper stage?
So we have the hold and release mechanisms that are attaching the satellites to the dispenser, and there will be a pyrotechnic bolt that will be used to detach the satellites, and then springs that will gently push away the satellites.
Good view there of our planet below us, Australia there, and Antarctica in the south. Getting close now, about 8 seconds to the scheduled separation.
Séparation des satellites Galileo FM33 et FM34.
And we have confirmation there of separation of our 2 satellites. And the parameters on board are all normal. Our 2 satellites moving gently away from the mothership. As you described there, David, the springs pushing them away. So our 2 Galileo satellites have separated successfully. They are now on their own, flying free. Galileos 33 and 34 are now scheduled to begin their first steps, stabilizing, orienting themselves and getting ready to fully wake up. And the teams at the Galileo Control Center in Oberpfaffenhofen in Germany are now following all of these operations closely from the ground. The next big moment will be in approximately 50 minutes when we'll hear how the satellites are getting on. And for now, everything looks to be progressing absolutely according to plan. Now, after that, it will take about 3 months to test and commission the satellites before they are ready to become operational and start their job. And this process of transitioning them from passive cargo to an autonomous spacecraft is called LEOP, Launch and Early Orbit Phase. It's a very important phase. Somebody who knows all about this is Fabio Angelotti, who is a space segment leader at the EU. He's just said the passivation is starting. EU Agency for the Space Programme. Fabio, thank you very much indeed for coming to join us. So, Fabio, what's happening up there in space right now?
Thank you, Katie. So, satellites just separated from the launcher. We are now in the LEOP phase, launch and early orbit phase. EUSPA is responsible for this very critical phase of the mission. As we speak, my colleagues at the Galileo Control Center in Oberpfaffenhofen in Germany, together with our industrial partners, SpaceOpal and OHB and ESA project support team, they are taking command of the satellites. The first step will be to establish a communication with the satellites, and afterwards they will confirm that the satellites have been released in the expected orbit. Following this, there will be a confirmation that the solar arrays have been deployed and they are pointing towards the sun and the attitude of the satellites has been stabilized. Another important check would be that the batteries will be actually recharging. In the coming days, what we will be doing, we will start testing the main subsystems of the satellites to ensure that they have survived the harsh conditions of the launch. And if everything is nominal, we start moving the satellites into their final target orbital slot. Once we have reached this position, we start another important phase that we call IoT, in-orbit test phase. Only upon successful testing of the payload during the IoT will then confirm the full mission success. And it will be only at that point that we request the EUSPA sub, Security Accreditation Board, for the authorization to include in the operational constellation these 2 new satellites. And in this way, they will contribute actively to enhance the robustness and the reliability of our constellation.
And this phase is really critical, isn't it, for the success of the mission? But why is that?
It is. It is because in a very short period of time, we have different critical operations that we have to carry out. And any cap during these operations may put in danger the mission success. I was mentioning before the establishment of the communication link with the satellites. I was mentioning the deployment of the solar arrays. I was mentioning the pointing of the solar arrays towards the sun, as well as the charging of the batteries. Any anomaly in any of these stages, as I said, can put in danger the mission. Therefore, if there are these type of anomalies, it is very important, it is paramount for the mission success that there are fast decisions and a clear course of actions to recover the anomaly. And this decision needs to be fast, needs to be thorough, and the execution of the set of actions needs to be fast in order to avoid impact on the mission success.
A lot of work.
It is.
A lot of work, a lot of concentration.
Yes.
And once the Galileo satellites have gone through this process, does that mean that EUSPA is then out of the picture, or do you continue?
No, not really, not really. Actually, another important part of our work will start, which is service provision. In fact, as the user-oriented operational agency of the EU space program, EUSPA has the responsibility to ensure that Galileo delivers high-quality, secure, and reliable services 24/7 around the clock. And we do that for the users. We know that today we have more than 4.5 billion users around the world relying on Galileo.
That's a lot of people.
Yes, it is. And it is also our responsibility to ensure that Europeans, both citizens and businesses, they benefit of the investment of the European Union in Galileo as EU sovereign asset for satellite-based navigation.
Well, listen, very best wishes to all of you and to the team, because you've got a big job ahead and a very, very important one. Thank you very much indeed, Fabio, for coming to chat with us. And best wishes. We're going to take, it's going to take about 40 minutes now for us to, before we expect to hear back from the satellites and hear how they're getting on and go through some of the processes that Fabio was just so wonderfully explaining. So we're going to take a break and we're going to come back to you after that. But let me just tell you before we go that when we come back, we're going to be going to Brussels in Europe. The European Commission is hosting a live event at their headquarters in Brussels for the launch of the Galileo satellites. It's called Galileo Launch 14, and we'll be hearing from key players and also from the user community. So it'll be really interesting. I highly recommend that you stick around and watch that. It's going to be really exciting. But for now, do stay with us. We'll be coming back to you in about 34 minutes' time. We'll be back here then. See you then.
Le pilotage est calme, les paramètres à bord sont normaux. La passivation se poursuit nominalement. Poursuite nominale de la passivation. Poursuite nominale de la passivation de l'ULPM. Poursuite nominalement de la passivation de l'ULPM.
Hello again and welcome back to our live broadcast, Road to Space, Galileo Launch 14. We are coming to you from the Guiana Space Centre, the European Spaceport in French Guiana. I'm Katie Haswell, and joining me still is David Iranzo-Graves. David, thank you very much for sticking with us throughout this long night. It's been a long launch. We lifted off from the pad. You saw those beautiful images there of the liftoff just after 2 o'clock here in the morning at the Guiana Space Centre. And you were looking there as well at pictures here of the teams in the Mission Control Centre inside what we call the fishbowl. The operational teams inside that protective glass. And who are we looking at here, David?
So these are the teams of Galileo from ESA and USPA, and they are standing by to get the confirmation on the status of the satellites.
Let's remind everybody what's happened so far.
So we lifted off a bit more than 4.5 hours ago from Kourou. We lifted off we traveled northeast across the Atlantic, 2.5 minutes of flight with the boosters, and then the upper stage continued the propulsion. The fairing separated 1 minute later once we were out of the atmosphere, and we continued with the Vulcan engine propulsion until 7 minutes and 40 seconds. After that, the main stage separated, and we had first ignition of the Vinci upper stage engine, ignition that lasted 11 minutes, putting the launcher into a long coasting phase that lasted 3 hours and 20 minutes. And we then reignited the upper stage for a second short boost of 2 minutes, circularizing the orbit at 23,000 kilometers, and then the Galileo satellites separated from the launcher, and the stage was passivated. And we are now waiting for the final confirmation on the status of the satellites.
Indeed, and as you say, the satellites were separated, injected into space about 40 minutes ago, and at that point the teams at the Galileo Control Centre took control of their new babies. The satellites are now going through a number of crucial operations, and the teams on the ground will be following these operations, no doubt with extreme concentration, David.
Yes, that's right.
And these first minutes and hours are vital for the mission. We're now waiting to hear, as you said, David, for the teams to see how the satellites had been getting on during this phase. So while we wait to hear, David, let's just talk a little bit about the future, because we've got a lot of launches coming up next year, and the next launch is very exciting and very important, isn't it?
Yes, our next launch will take place early next year. It will be a very important launch for us, because it will be the first Ariane 64 launch, so the version of Ariane 6 with 4 boosters. This will mean a significant increase in launcher performance, so adding flexibility. We will be able to deliver more than 20 tons to a low Earth orbit, and a configuration that will allow Ariane 6 to deliver satellites also to multiple orbits. And it's an ideal launcher version for launching large constellations. This will also integrate for the first time a long fairing, allowing a larger capacity in terms of volume as well.
And one of those constellations, of course, is Amazon Leo, which will be the next launch. Some very, very important passengers there.
Yes, this first Ariane 64 launch will carry the first batch of Amazon Leo satellites launched by Arianespace. There will be 32 satellites on board. Amazon Leo is, of course, the large Amazon constellation being deployed to provide wideband communications around the world. And the Amazon Leo satellites for this first launch are already here on the launch site in French Guiana, and they are being ready for the launch. And the launcher elements for this Ariane 64 launch are now being picked up by the Canopé vessel at the different harbors throughout Europe. The boat was in Bordeaux a few days ago in France, picking up the booster elements. It is now arrived in Bremen, Germany, to pick up the upper stage of the launcher. And just before Christmas, the boat will do a last stop in Le Havre, in France, to pick up the main stage. And then it will cross the Atlantic, arriving in Kourou at the beginning of January.
And it's a very important boat, Canopy. It's been designed specifically to transport the sections of the Ariane 6 rocket. And it's a very exciting boat because it's got sails, it's got masts and sails. So it uses hybrid propulsion in order to reduce emissions. And I think a lot of shipping companies will be taking some inspiration from that, setting trends here in the space industry. Just a reminder that we're waiting to hear from the status of the satellites, and looking here at the teams in the Mission Control Center at the Guiana Spaceport inside the fishbowl. The fishbowl is our pet name, if you like, for the protective glass there containing the operational teams. And then on the outside of the glass, you can see the invited guests who are watching the launch today. So, David, let's chat a little bit about what else is coming up next. It's going to be a very busy year, isn't it?
Yes, our launch rate next year will be picking up. And the objective is to reach, of course, in the coming years, our full operational launch rate of 9 to 10 launches per year. And we will have another important event for us next year, which will be the introduction of our Ariane 6 Block 2 configuration. This Block 2 configuration will introduce several launcher improvements to further increase the performance. The main improvement will be the larger solid boosters. We will be adding around 15 tons of additional solid propellant in each booster. And actually, these new boosters were one of these new boosters was fire tested here in Kourou last April, and we should have these boosters flying on Ariane 6 around mid-26.
Operational teams here in the Mission Control Center. It's been a very busy time. We've had 3 launches, David, haven't we, in the space of a couple of months before Christmas. So and of course it just proves that it's possible to be preparing for several different launches at the base at the same time.
Yes, that's right. Arianespace has had a few launches. We had the last Ariane 6 launch beginning of November. We had a Vega C launch end of November, and then now we are mid-December. So yeah, we've had a busy end of the year.
Just a reminder that we lifted off from the pad just after 2 o'clock in the morning here at the Guiana Space Center with our 2 Galileo satellites attached to the top of our rocket, our Ariane 6 rocket, the 5th Ariane 6 rocket to lift off from the pad here at the Guiana Space Center, where it's had an entirely new launch pad and launch zone, dedicated launch zone built for it.
Yes, that's right. A full new launch zone that was built between the.
Succès du lancement confirmé.
And we have confirmation there that we have, as we can translate from the range operations manager, success of the launch. So that's very good news. We are looking at some very happy faces here, David, in the Mission Control Center.
Yes, indeed. All the teams are now relieved, meaning that the satellite has been contacted. The satellites have been contacted, are in good health.
So the satellites have gone through their first few operations. They've had to open their solar panels, call home, tell everybody how they're doing, and the teams in the control center have been following those. Now, this has been a long night, it's been a long launch. The satellites had a long journey. They had to travel very high up into space, didn't they?
Yes, that's right. It's been a long mission, but a successful one.
And a nice pre-Christmas success. Everybody congratulating each other here in the fishbowl. The satellites on their orbits doing what they're supposed to be doing. Waiting now, hopefully, to hear from Caroline Arnoux, who is the head of the Ariane business unit. And she will be giving us a little bit more information. In the meantime, I can see some big smiles there here in the fishbowl. Let's go over now to Caroline. Caroline, well, this is very good news, isn't it?
Yes, very good news indeed. Today, Ariane 6 successful flight marks a new step in Europe's independent access to space. Ariane 6 perfectly placed the two Galileo satellites into orbit in the frame of its very first launch dedicated to Galileo program, the Europe's own navigation satellites, benefiting to billions of users all over the world. The news are excellent today. The launch is, of course, fully successful. The injection accuracy is perfect, and we have been informed by the customer that both satellites are transmitting telemetry nominally, and that the solar arrays have been deployed successfully. So excellent news today, and I have a warm thank for Arianespace and Arianegroup teams who have demonstrated once again their operational excellence. I'm also very grateful for the continued trust placed in Arianespace by your partners, ESA, European Commission and EUSPA. This year, 2025, has been for Arianespace a very dynamic year with 7 successful launches, 4 Ariane 6 and 3 Vega C. Following this incredible year for Ariane 6, we are targeting many more Ariane 6 launches ahead. So go Ariane 6 and follow us next year. Thank you.
Thank you very much indeed, Caroline. So it's been a great launch. As you said there, flawless liftoff, followed by confirmation of separation of both satellites and that they were injected onto their correct orbit. Our 2 spacecraft are now sending telemetry home. That's the range operations manager announcing the family photograph for the teams. And the solar arrays are deployed. They're now travelling on their own to their operational orbit, 23,222 kilometres up, and they're going to be spending the coming months doing their launch and early orbit phase. So, an important day for Europe. An important day for independence in space. We are now going to go hand over to Brussels. The EC, as I said earlier, is hosting an event at their headquarters for the successful launch tonight. It's called Galileo Launch 14. It's hosted by Alex Cadier. They'll be meeting key players, and it's really, really going to be exciting to hear from them. So a lot to look forward to. Before we sign off, I would like to say a huge thank you to you, David, for joining us. It's always such a pleasure to have you in the commentary box. Thank you.
Thank you, Katie. It was great.
So we would like to say congratulations. We are going to sign off and say goodbye from David and from me, but we are going to hand you over now to Alex and Galileo Launch 14.
Welcome back to Brussels. I think the first thing we need to do, because we've heard very successful, we've heard perfect, based on what we heard from French Guiana. So many of you know here in this room that very successful and perfect is not always easy to get to when it comes to space. So much work from the European agencies, from Ariane, from all the partners went into this. Can we all give them a round of applause, but loud enough so they can hear us in French Guiana? I know it's early, I know it's the morning, but we can do more. As I said, a very proud moment, a very proud day, and it's not easy to get there. Again, colleagues in the front row nodding whenever I say it's not necessarily that easy to get there, so it's really a moment of celebration. And let's look at some highlights of how we got to this point by looking at the highlights of this very launch. I don't know who you are, if you work in the space sector or not, that will never not be cool. It just won't. We're going from strength to strength here in Brussels, and for those watching online as well, they're going from strength to strength in French Guiana. But for us, the best possible way to go from strength to strength is with our first speaker. I'd like to invite Commissioner Kubilius to join me on stage and to say a few words to everyone. Please join me in welcoming him.
Good morning, Kourou. Good morning, Paris. And good morning, all of you here in Brussels. It's always such an exciting moment. But the wait is over. Ariane has launched. This is a massive achievement, and this is a good news for all. We all use Galileo in our phones and cars. 4.5 billion people connected to Galileo every day. That is more than half the population of the world. Galileo helps cars to drive automatically. It helps farmers to grow food. It helps to ships to navigate. It helps to save lives at sea. And brings many more benefits from space right here on Earth. Galileo is already the best satellite navigation system in the world. And soon, Galileo will get even better. once these 2 new satellites are fully operational. Galileo will be strong and always available. We're expanding and renewing the Galileo constellation, ensuring global coverage and operational capability. More satellites in the sky means a more robust, more reliable signal. Today's launch ends a year of successful launches. And that is important for another reason. We are at the start of space revolution. Europe's future in space, our strategic autonomy on Earth, depends on our access to space. To benefit from space, we first need to get to space. So I thank all involved, all of you are here at the European Spaceport, and everyone here who made this possible. The European Space Agency, the European Space Programme Agency, Arianespace, and my colleagues here at the European Commission and DEFIS, of course. Thank you, all of you.
Thank you, Commissioner, for those words. I think we're now going to hear from some European lawmakers, some MEPs, of course, who will be invested in this, like so many of us are. I think they are joining us from Strasbourg, so a busy week there, but taking some time to speak to us. We can see them there. Welcome. Thank you so much for joining us and for your time. We'll start with Elena Donazan, who we can see here in the middle, and then the gentleman will join afterwards. Welcome.
Good morning, everyone. I'm pleased to be with you today on this historic day for European space history. Galileo, together with the entire US space program, is a clear example of what Europe can achieve when it works together. It demonstrates that a pragmatic, results-driven European approach can deliver truly outstanding results. Galileo is today the most accurate global navigation satellite system in the world, as Commissioner Galileo said. It supports citizens, public authorities, and our economies across a wide range of applications. From maritime transport to agriculture, from energy security to road safety. It is a concrete and strategic European success, and we should be proud of it. As a rapporteur of the European Space Act, I strongly believe that the Space Act must be closely linked to the space program and to its flagship missions, such as Galileo. With clear, simple, and predictable rules, Europe can lead by example in space. We can be champions also in safety, resilience, and sustainability. In doing so, we will strengthen Europe's strategic autonomy in the space domain and continue to invest in space research and innovation. Galileo shows us that when Europe delivers, it delivers excellence. Our task now is to build on this success and ensure that Europe's space policy remains ambitious, pragmatic, and fit for the challenges ahead. Go Galileo, and Merry Christmas to everybody.
Good morning to everyone. Indeed, to fully unlock Europe's ambition in space, we needed to maintain our role as a scientific and technological powerhouse in a leadership position for Earth observation and the accuracy of the satellite navigation system. But more importantly, Europe must rapidly grow in terms of autonomous access to space, vital for our security and economic growth. Access to space also ensures that space infrastructure remains reliable, secure, and aligned with EU values and interests. The launch of these 2 Galileo satellites on board Ariane 6, together with the recent Sentinel-5A and ID launches, underscore a commitment in this direction, which we strongly welcome. The additional satellites will expand the existing constellation and guarantee the continuity of the Galileo system, ensuring full coverage and operational capability, as well as enhancing its signal robustness and accuracy. 100% funded by the EU, Galileo is the result of European actors joining forces to deliver excellence. Thank you to all of you for making this launch happen, and go Galileo and go Europe.
Bonjour à tous. Hello, everyone from the European Parliament here in Strasbourg. Congratulations first for the success of this morning and for this night in Kourou, of course. Beyond the Galileo satellite, there is a European chain of work on jobs. From Bremen, where the satellite is built, to Fiumicino in Italy, where Galileo is operated every day, onto Kourou, where Ariane 6 turns European industry into European capability. This is not just cooperation, it is continuity. Jobs, skills, and know-how that stay in Europe generation after generation. In today's geopolitical context, that matters. Because when Europe loses industrial capacity, it rarely comes back. This launch shows that when Europe chooses to invest at scale and over time, it protects its workers, its industrial base, and its strategic choices at the same time. This is why, as the European Parliament, we are convinced that Europe needs a stronger EU budget for space, a stronger budget for Earth observation, for telecommunication, space awareness, launches, and of course, navigation. Europe needs more launches like this, and that means more investment in our EU space budget, not for prestige, but for jobs, for sovereignty, and to protect Europe's future. So we count on all of you to help make this ambition a reality. Thank you to all the teams across Europe who made this launch possible, and of course, go Galileo.
Thank you very much to the three MEPs from Strasbourg for those messages, and good luck with what I'm sure will be a very busy week indeed. Thank you so much. A reflection I had listening to those lawmakers is that not only did we launch 2 satellites into space, but we also managed to make the Commission, the Parliament, and several European agencies happy about the same thing on the same day.
Bravo, bravo.
I promise I won't go into any more politics than that. I can see my deafest colleagues saying, please don't make any more jokes about politics. But clearly, that in and of itself, that cooperation is incredibly important. We have been to Kourou, we have been here in Brussels, we have people watching online. We've just heard from Strasbourg. In a minute, we'll hear from Paris. I'm starting to plan a deficit-aligned holiday plan based on these destinations already. But I want to start about the cooperation between agencies, which is so important to this project. And we'll start by just very quickly looking at the role that EUSPA plays, and I'm sure we'll hear more about that later in this launch.
4, 3, 2, 1.
And now I think a brief introduction to what, the role that EUSPA played. Of course, we will also want to hear about the role that ESA played, the European Space Agency, in this important launch. And for that, who better to tell us about that than Dr. Josef Aschbacher, who is connecting from Paris. I'll just see if he's here. Yes, he is. Director General, over to you.
So good morning to everyone in Brussels, in Kourou, the European Parliament in Strasbourg. I'm joining you here from ESA headquarters. We have the ESA Council today and tomorrow, so unfortunately I cannot be with you as much as I would like to. As you can imagine, this is always a highlight, but really happy to say a couple of words from my side here. So it's really a pleasure and an honor to address you from here from ESA headquarters. The year 2025 marks 3 decades of navigation programs at ESA and the successful launch of 2 new Galileo satellites in another proud and well-earned moment in that legacy. Today, we honor the foresight of those colleagues who decades ago were brave enough to introduce a new idea to stretch Europe's industrial and technical capacity and to believe that Europe could lead the world in a technology so essential that it underpins our everyday lives. Galileo stands as the world's most accurate global navigation satellite system. Since Galileo was declared operational in 2016, it has provided unprecedented position and accuracy to billions of users worldwide, contributing to saving thousands of lives and added authentication to mitigate and threat of spoofing. Every new satellite added to the constellation strengthens reliability, continuity, and resilience for users across the globe. Following commissioning, the satellites launched today will join a constellation of 29 active satellites, further reinforcing the system's ability to guarantee 24/7 navigation services. We are now 2 launches away from completing Galileo's first-generation fleet, closing 1 chapter and opening another. In the coming years, Galileo's second-generation satellites will further enhance performance and resilience, integrating seamlessly with the current fleet to form Europe's largest satellite constellation. This was Galileo's first launch aboard an Ariane 6 rocket. The capability to carry out institutional launches using European launchers developed by European industry under ESA project management and launched from European soil is fundamental to Europe's autonomy, security, and credibility. Ariane 6 is a cornerstone of that capability and remains mission-critical to realizing Europe's strategic priorities. Galileo is a symbol of exquisite European cooperation between the European Commission, the European Space Agency, and European industry, utilizing the best of the best talents and expertise across Europe to build and operate such a system is something that all Europeans can be very proud of. I want to salute the engineers, the scientists, and support staff that have contributed not only to today's launch, but to making Galileo an undeniable success story for our great continent. ESA is responsible for Galileo's design, development, and evolution, delivering a system that is trusted worldwide. As the year draws to a close, this launch reminds us not only of Europe's technological strength, but also what we can achieve when we invest together in long-term vision, shared capability, and common purpose, using space to serve citizens, strengthen resilience, and contribute to peace and stability on Earth. And thank you very much from my side. Congratulations to everyone, and it's a real pleasure to see this success happening today. Thank you.
Thank you so much, Director General. A pleasure to see you. You mentioned exquisite European cooperation, so let's have a bit more exquisite European cooperation here in Brussels, and I'll invite our panelists to join me on stage to talk about this. We have, of course, Rodrigo da Costa will be joining us from USPA. We'll have obviously a lot of questions on that. The Chief Executive of Arianespace will also be here, David Caveolis, and Sonia Toribio Fernandez, the head of Galileo Ground Segment Office for the European Space Agency, and last and certainly not least, Paul Flamand, Deputy Director for Space Policy, Satellite Navigation and Earth Observation at the European Commission. If you could all join me on stage. And the rest of you can join me in welcoming them. So welcome all. You're all looking rather relieved for some reason. I can't imagine why. David, I'd like to start with you. We saw the highlights of the launch. Really simple question. How does that feel, those seconds leading up to the launch, for you personally? I can imagine a slightly nervous moment.
You know, what is magic is that you never get used to it. I remember my first launch was this year. I'm still quite young in the business. It was for CSO3, so military satellite, very important, at a very special moment just after the American elections. And the tension was total. And I thought and I hoped I would get used to it, be more relaxed. And the reality is that not at all. And even when this is at 2 a.m. in Kourou, you are not relaxed at all. At the same time, what is fascinating is to see that the teams remain very focused. They look calm, but I can tell you that everybody knows that a lot is at stake, really.
I mean, it was a really quite incredible moment to witness. Let's get into it. Let's get into what the benefits are, how this works. Pearl, I'll start with you. Talking to colleagues ahead of this panel, someone said to me, oh, Pearl knows everything, so you'll be fine. So no pressure at all. We'll just turn to you on everything, if that's all right. No. Let's break down very simply the added value here. Why these satellites? What's the value? What's the benefit?
So the fact that we have 2 more satellites is important for the reliability of the constellation, to make sure that if there is something happening to one of the satellites, we are covered by other backup satellites in orbit. But I think that what really matters are the services that Galileo are providing through those 2 satellites, but also through the other ones. So we have this open service, and everybody speaks about that, but we also have a panoply of other services. And I like that in this roundtable, we start to speak also about those other capabilities, evolving capabilities of Galileo. So I will not take that time right now, but maybe later in the discussion, I think we should focus on all the benefits brought by the Galileo services.
Noted. I will definitely be coming back to that. Rodrigo, I'll turn to you. Just an operational standpoint, talk to us about USPA's role in ensuring the continuity and ensuring the operations side of it, perhaps in parallel to that, and what the users will get from that.
Sure. So USPA is responsible for the exploitation of Galileo. That means, of course, the 24/7 operations. It means maintenance, and it means a number of activities that come with it. It means as well securing the security of the constellation is critical, is very important. Yeah, we do that, of course, with our industrial partners. They play a key role. And for us, the focus is really service continuity. So on all these services that Paul was mentioning, all the signals that the satellites are sending every day, used by billions of people around the world. Our focus is really to make sure that they are continuous and they are always at the expected standard. Now, clearly, these 2 satellites have an important contribution for that. So if I focus for a moment of our role in, let's say, the overall launch sequence of what we saw this morning, our teams took over the satellites just after they were separated from the launcher. So they went up with the rocket at a certain point in time. They separated from the rocket when they were very close to what will be their final destination. And that was the point where the satellites, the first communication occurred between our teams and those satellites. And then we checked that everything was okay, everything as expected, opening the solar panels, etc. And now starts the next phase. Right now, people continue working, and they will continue working for the next couple of months, where they will test, they will calibrate, they will make sure that everything is okay and correct, so that we can say, yes, those 2 satellites, they can add to the other almost 30 that we have there, and they can come into the operational constellation.
It's nice you've got different stress points at different parts of the process. Ariane had the first stress, then they hand over the stress to use, but it's a nice, certainly a cooperation on that. Sonia, I'd like to turn to you and ESA's role in this. What kind of challenges, opportunities do you foresee in aligning technical capabilities with the broader strategic EU goals?
So ESA role is the design authority of the Galileo program.
And one of our main challenges is to deliver. Once the user requirements are specified, then ESA is responsible of the design to ensure that we procure all the necessary infrastructure and that we deliver. And we have very tough customers that they want that we deliver in time, fitting with the security requirements and fitting with the good quality. So for sure, at European level, we really need to make all an effort to accelerate and to deliver. And for sure, IRIS² is like our next milestone. And in terms of opportunities, I started in Galileo 25 years ago as a software developer. I have been growing up, and for me, is the amount of opportunities that a program like Galileo offers to the European citizens. As Mr. Flamand was saying, all the new services that we really need to talk about, the possibility to define together with our customer new opportunities and to really implement it and make it working is really, a great opportunity for all of us.
Well, I'd be a pretty poor moderator if I didn't pick up on that straight away and go back to Paul. I have two of my panelists saying that we need to be talking about those new opportunities. Paul, very naturally, I'll bring you back on those.
Okay. First, I'd like to start with the fact that if you speak with your neighbor or some relatives and you ask them, oh, by the way, how do you think you get your position on your mobile phone or in your car navigator? They still continue to speak of another system, not about Galileo. And there we really need to make an effort to have people understand that the technology they are using is a European technology. And this was developed here in Europe by all the member states, by all industry. It's a real and nice success that all Europeans can be proud of. It comes through our democratic system. We have the knowledge, we have the brains, and we are able to put a very nice system in place. So about the services, we have effectively the open service that you can use everywhere. But Galileo also offers something that is unique, and it is an accuracy which goes up to 20 centimeters. 20 centimeters is the distance between those two glasses, and this is based on signals coming from space 23,000 kilometers away from those glasses. This is marvelous. I'm an engineer, I'm still astonished by the fact that we are able to do those things. And then nowadays, there are places where satellite navigation signals got interfered with. There is what we call jamming, there is what we call spoofing. And thanks to Galileo, now there is a system whereby we put in our signals an electronic signature, which we call authentication. And therefore, spoofers cannot spoof Galileo signals anymore, because we have something which discards all signals which are not coming from Galileo, and we are sure that our Galileo signals are those ones thanks to this electronic signature. Can I continue on the signal? Okay, so very soon, next year, we're going to come with a new service which is called Emergency Warning Satellite Service. Therefore, if something happens somewhere, the local authorities or the national authorities will ask Galileo to broadcast a signal to the people who are located in the region where there is a danger, whether a fire, a tsunami coming. If there is a tsunami, all people on the beach where the tsunami is coming will be warned in their mobile phone thanks to Galileo. This is really something new which will make news next year. And then last and not least, next year we're going to have also what we call the public regulated service. And this is a service which is devoted to our governments. So they will all get special accesses to this PRS service, and they will be able autonomously to do whatever they want with this PRS service, whether for defense, whether for any other thing. And this is also unique with Galileo.
I think it's also important to remember about the foundations. In these new systems that will be rolled out, they are still European-funded, civilian-led, and in a way that perhaps competitors who will remain nameless, as you called them, another system, have less of that made in Europe, certainly quality. And also, I think it's quite an achievement, as we saw with the cooperation between agencies. Rodrigo, I'll bring you back on this, because, you know, new systems will be your problem. Or your joy, depending on the day, I'm sure. Are you looking forward to these new developments?
Absolutely. Mostly the joy, because as the user needs to develop, the system needs to develop. And for example, when we look at satellite navigation, and we started with EGNOS many years ago, then coming with Galileo. Now Galileo is developing, it's coming into a second generation. Obviously, also from our side, we are also starting to look what will come after that second generation. And there, of course, the work together with Commission and ESA on what could be a low Earth orbit position navigation and timing solution is very important. Because when we started using satellite navigation, actually when we started using space data, but when we started using satellite navigation years ago, I think no one honestly thought that now in 2025, more than half of the applications we have on our mobile phones are using this technology. I think it was not in the mind of anyone. And every year, every week sometimes, we discover new applications, we discover new user needs. And it's to those that we have to answer, because the success of Galileo, the success of the EU space program at large, but the success of Galileo is linked to two key factors. First and foremost, of course, our ability to serve our critical users, our key users, governmental authorities, and those that use Galileo in critical circumstances. That's point number one. But point number two, also very important, is the ability to create value in the European economy. And we create value by creating solutions that make life easier, make our businesses more efficient, add value in general. So we are in presence, I get the question sometimes, is Galileo now ready? Yes and no. Galileo is ready in the sense it is providing services, everyone is using it. Galileo will never be ready because it will be continuously evolving the same way that our society, our economy evolves and our needs evolve. Galileo, and if you want satellite navigation, will continue evolving the same way.
I'll come back to you in a minute. David, I want to bring you in on this, because of course you're going to have to follow this adaptation, and Rodrigo was just saying that the situation as it stands in 2025 could have hardly been imagined many years ago. What's next for you?
Well, you know, Ariane 6 has been developed in 2014 onwards, and when the project was launched, it was just after the invasion of Crimea by Russia. And at this moment, everybody thought that it was not possible any longer to depend on Soyuz, because before, up to quite recently, we used Soyuz to deploy Galileo. So now we have Ariane 6, which is perfectly designed to deploy Galileo, and I think that today's success is a proof that you, at European Commission, at ESA, at USPA, you were right to believe in us, you were right to believe in Ariane 6, which is a very good launcher. A thing that is very important is that I think that Ariane 6 is one of the most, if not the most versatile launcher on Earth today. The reality is that we can deliver any mission with Ariane 6. So today we delivered this generation of Galileo. Of course, I know that you are all very creative. I know that the satellites will evolve. Probably the mission will become even more complex and not even more simple. My message is simple. With Ariane 6, we can deliver any mission, so we are there to stay. We are there to launch this generation of Galileo, the next generation, and maybe the generation after.
Quite a clear pitch from Ariane that you'll match the ambitions of your partners in this. Sonia, as I said, I'll bring you back. On these new developments, ESA's role in this?
Well, for sure, the Galileo satellites that we are developing now, they have a lifetime of 15 years. As Rodrigo was saying, the society is evolving. We need to provide new services. We need to provide new capabilities. And therefore, what is coming with the Galileo second generation is that we will have satellites that can evolve. We will have a very configurable navigation antenna on board, and we will have as well a ground segment that can really evolve and improve the time to market. We need to invest in new technologies. For example, the intersatellite links with optical technology is one of the trends. We need to include quantum, and for sure we are recently very much investing on artificial intelligence. So our trend is to look at the new technologies, at the future, and really to continue improving the robustness and resilience of the system.
Now, it wouldn't be a panel in Brussels without in some way mentioning the MFF, so we're going to go there. Pud, I'll come back to you about, not necessarily the MFF itself, but about where the key investment areas are going to be for the Commission. What's the priority?
So in terms of satellite navigation, obviously, first of all, we need to continue investing in the assets that we have. So we have the Galileo constellation, we need to continue operating it, we need to continue buying new satellites and evolved satellites of the second generation. But then there is a new technology in terms of satellite navigation which is popping up, and this is instead of launching satellites at 23,000 kilometers, you launch satellites much closer to the Earth, what we call low Earth orbit. And there you can put many more, you have to put many more satellites so that you always have satellites in visibility. And it brings a set of advantages for some of the functionalities of satellite navigation. So therefore, we intend to develop this new technology as a new orbital layer in the Galileo constellation. What is pretty good is that the European Space Agency just finished their ministerial conference a few weeks ago, and they have decided to invest into developing the technology for this low Earth orbit positioning, navigation, and timing. So therefore, when our MFF will be there with budget on the table, we know that we will be able to build this new Galileo layer thanks to the technologies that our ESA colleagues will have developed. And then there is a second element which is also pretty important, because you asked what do we have in the MFF. So we know that the signals coming to Earth in terms of satellite navigation are pretty weak. I mean, if it was light, you wouldn't see the light from the satellites, okay? It's not light, it is at a certain frequency, but the signals are pretty weak. And there are nowadays people who are trying to produce interferences on our signals. And I explained to you already this issue of the authentication. But what we would also like to do is to offer the users some monitoring services of those interferences. We are not interested to know who is producing the interference. This is for member states, intelligence, etc. But we'd like to offer the users the possibility to see whether the signals they are making use of are interfered with or not. And this is one of the further opportunity we want to offer in the next MFF. And then to finish, we also want to make positioning and navigation and timing services more robust, not relying just and only on satellite navigation. For example, we know that the timing service is pretty important, because as we said, in the financing sector, in the telecom sector, energy sector, synchronization is very important. And if you lose synchronization from satellite navigation systems, then you have a problem. And therefore, in the MFF coming in a few years, we intend also, or we propose, to develop ground timing distribution systems.
So I'll follow the thread like I did in the last part of this discussion and go to Rodrigo, because of course new services means continuity, and round we go. Give us a broader sense, though, of how USPA ensures that continuity, that reliability, and that trust, that crucial trust with users.
Thank you. I mean, it's obviously by continuous operations of the satellites and the systems, the ground segment, also continuous maintenance. I mean, these are all very complicated systems. People, I don't know if there is a good image of what it means, but a system such as Galileo are many computers, computer rooms on the ground, antennas, stations, of course in our control centers in Oberpfaffenhofen and in Fucino, but in stations all around the world, and of course you have the satellites as well, and all these needs to be monitored, it needs to be managed, needs to be maintained every day of the year, 24/7. So this is really a big focus, and we need to do that to make sure that the signals and the data continues to be produced in a continuous manner. So bringing all this together is certainly a big challenge. But then we are also facing external challenges, and I want to highlight that. I mean, Galileo is very successful. Everyone is aware that Galileo is very successful. Everyone in the room, and I'm sure most of the people that are listening to us, they are very happy that Galileo is very successful, but there are some that are not. And what does that mean? It means that Galileo being so successful, it is also the subject, it is also the target of ill-intentioned actors that may want to disrupt it, and may want to disrupt it from a physical point of view, yes, but most importantly, I think from a cyber point of view. So the protection of the system is very important. There is a lot of work that has been going on in the program of ever raising, if you want, the cyber protection of Galileo, both from the development and design side here done by the European Space Agency, from the operational side done by us, many measures. But on the other hand, there is, if you want, a permanent insatisfaction because there is never enough. And not being enough, it's something that we will continue working. I think if we manage to combine all those things, a well-protected system, a well-maintained system that is performing, I think we will continue being the most precise navigation system in the world and a very robust, very resilient one.
There's always a reflection I have when I come to these panels, when I come to these events. I know the user end of the technology, and I, as a relative simpleton, go, oh, that works really well. And I tend not to remember the hordes of people behind the scenes who have made it happen, the amount of work that goes into it. But I think, in essence, that may be the point, right? A completely seamless user experience, perhaps not seamless for the rest of us in the room, but that's, a wonderful achievement. I want to come back to a point you made, Rodrigo, about those threats, about the fact that, this may become an increasingly fraught environment. And David, I'll bring you in on that, because Ariane will be concerned about this. We'll be looking at this because you will also be a target of actors. What's Ariane's response to this?
Well, my point is that we are there to deploy sovereign missions and to make Europe stronger and stronger. We did it. We are currently doing it today, and will continue in the future. The good news is that we are accelerating. As you may know, we are engaged in a very fast ramp-up for the moment, and with today's launch, we are the fastest ramp-up ever of a Navy launcher. It can be a surprise because some people compare figures with the US and so on, but for a Navy launcher, including in the US, in China and so on, we are the fastest ramp-up. So now, of course, we want to work hand in hand with our customer to prepare the next generation, to prepare the future. And I want to raise a very important point. Sometimes, including here in Brussels, we hear rumors that Ariane 6 is not available because our backlog is full. Nothing is more false than this statement. And I want to be very clear on that. It's true that we have signed a lot of contracts, and it's good news, but the reality is that our DNA is to serve public institutions. So we will be there for the next Galileos, first generation, second generation, but we'll also be there for IRIS². We'll be fully there. We are able to deploy massively IRIS². We'll be there for German needs, for Italian needs. So Ariane 6 is ready for what is coming, and we are very excited to continue working with you.
A pretty clear message from you there. We're just coming to the end of our panel, so of course, this being the end of the year, that allows me the very easy question of all of you, if you could give me, in this space, one thing you're looking forward to next year. What is going to be, and we heard Paul talking about kind of new services being rolled out. We'll start with you. One thing that you're looking forward to in 2026.
Well, is the declaration of the public regulated service initial operational capability. It's something that we have worked very hard for many years. It's something that is really needed in Europe in the new geopolitical environment, and we are all very committed to achieve that.
Can you give us a little bit more on what the impact might be and why that is your top pick for next year?
Well, it is 10 years we are working in that service. We did a very large migration. The largest ground segment was deployed in 2024. After 1.5 years of service validation, I believe we are mature enough. And I think we shall all benefit, all the governmental service will benefit from that service.
Rodrigo, I'll move to you. Your top pick for 26.
Certainly the new services is a very important point. I would take it a little bit more generic, if I may. I think 2026 must be the year where we transform ambition into reality. There is a lot of ambition in space. We see big ambition at member states at the European Union level. It is the time to transform it into reality. It will be a crucial, you mentioned already the MFF, it will be a crucial year for the MFF and to see what is going to be the investment in space. We have to transform that into a reality because the European investments in space are fundamental for our economy, for our security, for our society at large. So that's my wish for 26.
No disagreement there. David.
You know, just before the panel, Paul was telling me that this model of Ariane 6 is not exactly the right one because this is Ariane 64 with 4 boosters, so not the one used today. But this is a very good idea to put this model on stage because next year we'll release this brand new Ariane 6. It will be the maiden flight of what we call Ariane 64, the heaviest launch in Europe. With this launch, we'll start deploying some constellations, but also some big sovereign satellites. It will be in Q1 26, and then we'll accelerate again and again. So my wish is that next time we do this panel in Kourou and we watch the launch of Ariane 64.
We'll see you there. I don't think it's a hard sell to get people to French Guiana.
Let's do it.
Paul, certainly last but not least, I gave you the unenviable task of going last, so you can't steal other people's ideas. But what are you most looking forward to in 26?
But first of all, I'd like to remember at least one thing, which is that we always say that Galileo is financed by the European Union, the 27 member states of the European Union. I think we need to add that Norway and Switzerland also participate into that, and it's very important because the technology on board the satellites is based also on important Swiss equipment, and Norway is offering us also territories which we wouldn't find if there was not Norway. And then since a few years we also have Iceland participating to part of our program called EGNOS. So now, in the course of next year, we will reach a point which is a technical point. Nobody will notice that, but a point where we arrive at a stage called full operational capability of the constellation. So this is a moment at which we can make very strong commitments on some of the performances of the system. So technical, but it's important to mention that. And then last point in terms of what will happen next year. You know, I've been working on this program since ever, and every year comes with surprises, difficulties, tears, sweating. I mean, it's always difficult. And what you see here today is only the tip of the iceberg, you know. There is so much work, so much investment, and every year is a bit different, even if every year is also a little bit the same, but there is excitement. And if you speak with the people working on this program, you will always find that sort of excitement. And this is what I'm trying to transfer, the excitement about Galileo, and also eventually the proudness of what we've done.
And that, I think, yeah, please, of course. That links actually perfectly to the first point you made about so much excitement behind this program and therefore the need for more people to know about it, for more people to understand that this is a European project, that this is an incredibly accurate project, as you demonstrated with your water glasses. And I think that excitement will carry on to end this panel and into next year. Thank you all so much for joining us.
Thank you.
Thank you.
Thank you very much.
So we appreciate the excitement in the room for this first panel. We'll go quickly on to our second panel before we wrap up. And we were talking about the users, of course. Let's hear from them. I'd like to invite Tom Trill, the Chief Executive Officer of Quanlix, to the stage, if you want to join us, as well as Daniela Genta, the President of Space Y, and Olivier Desenfants, from the Managing Director of M3 Systems. Help me all in welcoming them as well.
Thank you. After you.
Morning. Hi. Where shall I sit? Okay.
Perfect. Welcome. I'd like to do the reverse of what I did in the last panel and actually start with the end. Presumably you were listening to that panel thinking, what would I say if Alex asked me what I'm most looking forward to in 2026? We'll start with that, and then we'll carry on into our discussion. Tom, perhaps we'll start with you.
Yeah, thank you. Good question. When I saw the satellites launched today, earlier today, I visualized that signal coming to our chip sometime next year, and just the whole thing coming to life, you know. And when we reflect on the earlier speakers, how they emphasized the services insofar as accuracy and security and safety, you know, it continues to excite our team and our customers. So we're very much looking forward to that.
Just on that, actually, could you give us a little bit of a sense of what you do? So for those who are maybe not familiar, and this was on me, I probably should have started with that, actually, for those in the room. And that will also help explain what you're looking forward to next year.
Yeah, the hint was chip, our chip. So we're a semiconductor company. We make receiver chips for GNSS and IoT. So we've collaborated quite closely with USPA for the last several years. We've just recently completed the integration of the OSNMA service on our chip. It's in a pre-launch, market launch, not space launch, obviously, stage. We'll go to mass production in the Q1, Q2 timeframe next year. So many of our customers are very excited to see the implementation of OSNMA on a pre-launched semiconductor. And they've already begun to bake that into their own designs.
Daniela, we'll go to you. Same questions, just a little introduction, and then what you're most looking forward to for next year.
I think that you mentioned that before, the next MFF. So the 2026 will be a key year of negotiation for the future regulation, the Competitiveness Fund, and of course representing the user community of Galileo. We don't want not to be represented there, or we don't want to give the impression that only what happens upstreams and all the investment upstreams need to be in focus. Those are essential, but attention is also needed to the downstream sector. And for this reason, we hope to have a dialogue also with the Commission to see how we can improve the investments and how the downstream is accounted, particularly facilitating maybe procurement procedures to accelerate the process of standardization and certification so that the market adoptions comes faster.
We seem to be in quite a good location to be having a dialogue with the Commission, so certainly that's a hope. Olivier, again, I'll put the question to you, and forgive me for springing this on you guys, but I think it's a nice way of starting.
Okay, so just as introduction, M3 is working on test and validation. So we deliver solutions for end users to assess the performance and the way to use these navigation solutions in the systems and to integrate that in their product. I will take it easy for the first question, because I will just bounce back on what has been said previously. It has been said that 2026 will be the year for FOC, and basically that means that there will be a commitment on performance from the system, from Galileo, for the end users. And this is clearly what we see as users and interfacing with end users, that over time, the needs evolve from demonstration of what the system can do or what the system is to now, okay, I want to use it. And for that, especially for critical applications, I need a commitment on what the system will deliver. And so in this respect, it's a bit also what Juspa was saying, is that we're going from, it was from ambition to reality, I would say, from the promise of Galileo to the operations. Saying, okay, now there is a commitment on what the system can do, and so the end user will be able to massively adopt it for the critical applications. Okay, it's heavily used already now for the smartphone, for the smartwatches, for these kinds which are not so critical at the end. The future will be to use it for critical applications as well.
Sure, Apple Watch users and Garmin users like you and me will be highly offended that that's not deemed.
No, I use mine every day, but okay.
Of course, no, I take your point. Tom, I'll bring you in on this. Of course, you were saying that you're focusing on receiver technology. From that perspective, as a manufacturer, receiver manufacturer, how important is that continuous evolution? Because that partnership, and you said that earlier, your team's excited about what comes next, and we heard the excitement in our last panel as well. How important is that constant evolution for your perspective?
I think it's critical because innovation feeds innovation. That's the first thing. And in a system like navigation or PNT, the discrete parts are the weakest component in the chain determines the performance of the entire platform, the entire solution. So if our receiver is really poor, it fails the innovation that's in Galileo. If Galileo goes down, it fails the innovation that's in our chip. So there's this mutual dependency from an the innovation cycle perspective. So from that perspective, it's critical, absolutely critical. But more so specifically to Europe and Galileo itself, the market demands innovation. It demands services, demands products. And if we're not innovating in Europe, then someone else will. It'll come from somewhere. And the demand will and the market will navigate over to wherever the source of those solutions are, whether it's a different constellation or a different region in the world, or a different source of the solution. We're fortunate in Europe to have the best constellation, to have Galileo, and to be in such close proximity to this ecosystem, ESA, USPA, and the whole ecosystem. It allows us have a front row seat and direct access to participate in driving that innovation. But in other geographies, we see a lot of receiver innovation moving away from a pure dependency on the quality of the signal from a constellation and looking at ground-based augmentation, for example. And that puts more pressure on data centers. So why would we want to do that? There's enough pressure on data centers already. Why would we want to take a perfectly good solution from space and offset that with more data center stuff? So from and then I'd put a very myopic lens on my answer from a semiconductor design perspective. The more accuracy and the more secure the constellation, the less hard work that has to be done at the chip level. And therefore, we can take more of our resources and trade off more performance and power in other areas of our solution, such as sensors or other types of applications. So all in all, it has multiple different impacts and drivers within that innovation cycle, I would say.
I think if we were going to have a conversation about data centers, we would need a whole separate panel on that. But I completely take your point that it doesn't immediately make a lot of sense. Perhaps as a journalist, I'm a little bit guilty of the fact that I've been asking questions about what's next, what's the future, how are we moving forward, right? The journalistic instinct of, okay, well, this is today, what's tomorrow? But this is actually an incredible day, and this launch remains an incredibly exciting thing. So I'll slow my horses a little bit, and I wanted to ask you, Daniela, what it represents, a day like today, a launch like today, for the downstream community.
Well, it represents that Europe is back on strategic autonomy in access to space, and that also has to be allied with the autonomy for the downstream. Only if we align the infrastructure with service, and then also with the receivers, transmitters, chips, we can celebrate fully the all value. The ecosystem around PNT, positioning, navigation, and timing. Today, there was the launch of satellites of the first generation. There remain 4 satellites of the first generation. Then we will move to the deployment of the second generation satellites. And there we will have even more accuracy and robustness of the signal, which are with the specific features of Galileo that were reminded by Paul Flamand before, with the high accuracy services, the PRS implementation. All these features will announce the possibility that we have in terms of services.
I promised I wouldn't ask more questions about the future. I'm going to ignore my promise. The USPA market report says that there is going to be pretty significant growth in the GNSS downstream sector. What do you put that down to? What are the key drivers behind that growth?
The growth we know today in terms of, for instance, personal navigation, that there is an extensive use already of the GNSS system, also for sectors like transport, aviation. It was reminded how relevant it is to use GNSS and Galileo also to fight against the phenomenon of spoofing and jamming, and also more and more the synchronization of telecom and digital infrastructure, the also combination of GNSS signal with digital and AI. Of course, all this will announce the services and the develop. But as I said, it's very, very important that we keep developing our strategic autonomy also for the receivers, the transmitters, and the chipset. And thanks to the features of the Galileo signal, we will also increase the services for resilience and emergency services. And that will be also driving the market.
Absolutely. Olivier, I'm going to bring you in on this. M3 Systems has been working on accurate, reliable geolocation from the beginning. How has that long-term experience kind of shaped how you view the requirements of today's user community, and what are the kind of priorities in your perspective?
I will be back on what has already been said to some extent. You should have the same panel 10 years ago. The keywords of the panel would have been accuracy, number of satellites, precision, and these kind of things. Today, the keywords have been reliability, trustability, resilience, and this is quite well reflect the shift that that occurs from the early stage of Galileo, from the user perspective to today. Basically, okay, even if we're not still completely in full operational capability, the system is there, satellites are there, the service is there, everybody can use it every day. So basically, performance is assumed as granted. You're right, there is a lot of work behind the scene, but it's there. So the user does not look at this as, okay, what is the added value? what can be the expected performance, then now look at, okay, how can I use it operationally? What is the operational envelope? What is the guaranteed performance that I can get in real conditions in my operations? And specifically for critical applications in the aviation domain, in the rail domain, in the automotive domain for autonomous cars, everything related to high demanding safety applications or even security, are looking at this thinking, okay, if I want to use it, I want to be able to rely on it. And trust is really the key word. It was the case a few years ago. It's even more the case today because of the situation and the war on the Eastern Europe. The fact that threats are there, and so these users are looking at this saying, okay, how can I, again, be sure that the system that is not just a side feature, positioning being a side feature, it's really now at the core of the system. How can I rely on this, and how can be the indicator that, okay, I can implement it operationally in my day-to-day business?
Tom, I wonder if you felt the evolution that Olivier is describing and how kind of bigger picture, be it geopolitics, be other things, may actually impact your work.
Yeah, I think your use of the word trust is really, really critical now. And up to about a year or two ago, the words spoofing and jamming were synonymous with more military and non-civilian instances. But that's no longer the case. Civilian and commercial applications are as much at risk and are threatened by those bad actors as everybody else. So all of a sudden, our customers, regardless of what application they're using, if it's a pet tracker or something as common and low end as a pet tracker, they want to know whether it's going to get spoofed or jammed. It's almost a seismic shift in the expectations of a commercial business to have that security and safety baked into your device. And I think there's a ramification of that downstream, because in semiconductors, there's a 2 to 3 year cycle and tens of millions of euros required to redesign a part in response to a shift in the market, a megatrend in the market from the demand side. And that money has to come from somewhere ultimately. And it also is a little bit of a circular economy too, because it fuels more employment and so on. And we heard that theme emerge through some of the earlier speakers. And I was just thinking about the impact on us. What if? And yeah, it's the circular economy where these megatrends shift the business, that create more employment, more innovation, and more threats and risks insofar as that going offshore as well.
Daniela, from your perspective, that shift which Tom described as happening in the last couple of years, or maybe even a little bit longer than that, that seems to be the trend. And security, reliability will remain, if not even more so. I mean, I'm not going to ask you to predict the future. That seems a little unfair. But that will be a focus still. What do you think are the next challenges in that space of security and reliability?
Well, Galileo is a system that was designed to respond to the civilian user community, but has also some strong features that are going beyond that. So that is, in a way, it's already ready in that respect, I would say. Of course, there is a use of, because of the features of the signal, will be much more important for early warning services, emergency warning satellite services that were mentioned before, and also with the development of the terminals part and the receiving part. In that respect, there will be much more focus on strengthening the robustness and using the robustness of the signal, including from the user perspective. And the investment and innovation is also needed there. And it's needed that these investments are taken up together while designing also the system at the infrastructure level.
Yeah, I saw you agreeing. Did you want to add anything or jump in on that when it comes to the future priorities? I also saw you when I asked the question of, what comes next. You said that's it. You looked to say that was a slightly unfair question because I understand I am asking you to predict the future, but this will remain a priority.
Yeah, sure. Again, if you look at the commercial and marketing documentation from the GNSS manufacturers, a few years ago it was about, again, performance, accuracy, the number of satellites I can track, the number of constellations, whether it's single or multi-frequency things. Now, most of them at least are attending, which is this big event that is happening once every 2 years, once per year in Norway, which is the JAMA test, where basically all the systems can be tested.
Thank you so much.
So where all these systems can be tested against jamming and spoofing attacks. And most of the marketing, it has become a marketing argument for most of the chip manufacturers. So again, this for me, this is the translation of the fact that at the end of the day, what is really the needs from the user perspective is the trust, resilience, and reliability of these systems, and this also is showing that positioning and timing and velocity for some applications are really becoming key information, and this is driving the automatization of lots of systems and solutions in Europe. So for sure, this will remain key drivers for the futures.
Tom, I'll bring you back in on this of the upcoming services. Which are most critical to what you do, and perhaps what are you most excited to see?
Yeah, there are two upcoming. One that complements and augments OSNMA, and it's the signal authentication service. And I think that combined with OSNMA will give us a real trust zone insofar as the signal is authenticated at source. And it makes it much easier for us at the chip level then to re-authenticate and allow our resources in the chip to do other work. That's huge. And secondly, the timing service. And the reason we're excited about the timing service is because of its criticality in smart cities. And I think smart cities are coming much faster, but in a different shape than we expected. If you've been to San Francisco or Austin recently, you'll see the taxi service is dominated by Waymo, fully autonomous, camera vision-based cars. But that's not sustainable as the critical mass of vehicles on the road tips over to self-driving vehicles. You need some infrastructure, and municipalities don't have the money to invest in this V2V type infrastructure we thought about. So where's the security or the insurance policy coming from? It has to come from GNSS. And with Galileo implementing the timing service as a dedicated service, that I see as being a massive enabler that will be ahead of municipality infrastructure build-out in a smart city. I met with an automotive company last year, and they talked about the need in a city. Every intersection has to have a GNSS receiver, and then there has to be a central one to synchronize those four on the intersections. And now just map that out, overlay that in the city, and you think about the implications for a timing service from Galileo. Very exciting, very critical, and driving innovation again.
We'll stay with that excitement. I think that'll be our final point. Danielle, I'll ask you the same question. What are the services? What are we? Will be such an important evolution for the downstream community. What are the key things?
Well, as he mentioned, the autonomous vehicle, drones, all this is going to be a market and a growing market, and of course the features of the signal of Galileo are very variable in that respect, for sure. Also, we should make sure that whatever innovation is funded also with the Horizon Europe, for instance, instruments in Europe, is also helped then to be commercialized in order for Europe also to capture this commercial market. So the importance is to support not only the research, but also the commercialization, and USPA in this respect is with the member states supporting the industry, the SMEs, and working in this sector. The access also to venture capital funding is very important because there is a need to support to get to the size, then to be a player into this new market.
Olivier, to close, the same question about new services. What are you most excited about? It's an unenviable task to go last on these things. I recognize that.
Yeah, I would not point one specifically. I think that all the new features or the new services will have their own added value and use case. What is I think important is let's say 2 points. First, these new services that are really specific to Galileo are an opportunity for the European industry to develop, to create a market, to answer some needs, and basically to leverage on the investment that are done at the system level. The other constellation doesn't have these features, and so this is really an opportunity for the European industry to get involved in that. The second point would be that, to me, innovation creates value only when it turns into operations. And so I think this is really where we have to also to focus is on the way and on the support to move from technical premise again to the real operations. And this is also where I think Galileo has an added value, especially for the market that I know best, which are the critical market. If you take trains or aviation, the market or the lifetime of these products are quite long, 20 years, 30 years. And so these guys need a visibility on the long term of the system. And in this respect, Galileo being a civilian service, EU governed, with quite clear roadmap, with also consistent documentation, open, easy to access, are really key for those actors to jump in and to really implement and turn this innovation into operations.
A great point on which to end. Thank you all so much for joining us, and please join me in thanking them.
Thank you very much.
And thank you all for being here today. For those watching online, that is very nearly a wrap. We have coffee and pastries and other deliciousnesses behind the stage. So please join us just to have a little chat after this. It's been a real pleasure. And we will end as we started with the highlights from this extraordinarily historic launch. Thank you all so much for being here.